me. But this week, some experiments right here, boiling some stuff here. So, corner of the kitchen. My name is Amadeo. If you remember me from last week, we did some geology. We'll be at home. And today I want to do some science right here in the kitchen. So in the next half an hour, that's what I'm going to be doing. A lot of this stuff, you can do it really safely at home. When it comes to using stoves, obviously ask your parents. I can read comments actually if I go really close here. I can see that Karen is there and Jamie Hall and Beck. So hello everyone. Beck is Felix apparently. So hi Felix, how are you? So I'm actually a geologist. I don't know if you remember from last week. I introduced myself. I came from Spain and I introduced myself as a geologist because that's what I came to study. But here in New Zealand, I've been here for 20 years now, and I work at the Otago Museum. And I am a teacher as well, so I work in a school, and well, at the moment I go to many schools to do science, so I'm not so much a scientist anymore. I'm a science communicator. I really like doing science with any topic. So even though I really like rocks, and you might have seen that last week, I like all sorts of science. And of course, in the garden we did some biology and some geology. Here, what do you think I'm going to be doing? In science, I actually would do chemistry and physics. Say my name. I can't really read from this distance very well. It said my name, maybe. Yeah. If you have any questions, actually, write them, type them, because I'll be able to ask to read them. Hello Sophia and hello Karen. I don't know if you've tried this before. This is cabbage. Smells not very nice actually, and when you cook it, it doesn't smell any better. But it tastes all right, and it's actually something that in Spain, where I come from, we do quite a few dishes with. So I've got some here, and I've been boiling some of it here. And of course, this is purple. So the juice that comes out of it is also purple. Check this out. Oops. I'm going to put a little bit of it here. So this is cabbage. You might have done this already. And for some of these things, if you've done them, I'd like you to think a bit further in what's going on here. If you haven't done them, take note, because you'll be able to do this easily at home. For this experiment, you just have to boil some cabbage, and you get this liquid, which is kind of purple. That's the color of the cabbage. And then you can do experiments with it. Now, what I'd like you to think, and when you are later on in your kitchen as well, I want you to try to identify if what you're doing is physics or chemistry. So what I've done here, I'll show you. I've got a page, and this is something that you could easily do as well. Write physics in one side of the page and chemistry in the other side of the page. And anything that you see done in this lab, the kitchen, because really it is a lab, I'd like you to think, actually, is it chemistry or physics? I've always said that a kitchen is a really cool chemistry lab, because you're mixing chemicals all the time. Chemicals that you can eat, of course, but they are still chemicals. Water is a chemical. Salt is a chemical. So you have some chemicals that are solid, some chemicals that are liquid, some gases as well. There's vapor coming out of this. So chemistry is quite a bit of what you do in the kitchen, but also physics. And the difference, I'm going to tell you now, and then I'll do the experiments. And what I'd like to do is number my experiments here and see what I do most of in the kitchen. Do I do chemistry the most, or do I do physics the most? So in chemistry, we will have chemicals that you mix and something happens to them that means they change. A chemical change means that the thing that you have, the ingredient you have, has changed a lot, and it's really hard to get back to how it was. So I'm going to see what happens, for example, with this cabbage juice if I add another chemical to it, and I'll mix them. So I've got some. Actually, I might take the cabbage out and then you'll see the liquid. And the liquid is very, very purple. So purple is the color of the cabbage. And this is used, plants are used to see how acidic. So like vinegar is very acidic. How acidic some substances are. The cabbage is purple. If I put a little bit of vinegar, what color does it change to? See, the vinegar is actually clear, but it's made the purple cabbage pink. That means it's an acid, and we knew that. Vinegar, like lemon as well, is very acidic. So that is vinegar. I've also got here baking soda. I'm going to open it. And if I put baking soda is not acidic. It's very much the opposite, actually. So if I grab my spoon here and put a little spoonful, ooh, something amazing is happening, actually. I wanted to change the color of it, but it's also reacting. It's making heaps of gas. Check this out. Whoa, heaps of bubbles are coming out of it. And it's not pink anymore, but it's not purple either. The liquid is now blue. It's changed blue. Look, blue liquid. That means this is not acidic at all. It's the opposite. Basic. The liquid that I'm using here and changing is very difficult to put back in what it was. In fact, it's actually even giving gas. That is really weird and very cool. But that makes this chemistry. When we do a reaction and something happens, then we are doing chemistry. So I'm going to add what I've just done to my chemistry list. And this is the cabbage experiment. Cabbage. So cabbage is chemistry. When you are changing with vinegar and baking soda. What is physics? Well, let me show you an example of physics, and then I'll do more. Using this plate. Something else that I've done this morning, and I kind of messed it up. I've got this here. This is a little tray of eggs. And I'm really confused now because I know I boiled some of those eggs. At least one of them is boiled, but I can't remember which one it is, and they all look really similar. So how do you know if this one is boiled, or if this one is boiled, or if this one is boiled? I don't know. I've got eggs here, and I want to see which one is boiled. You can try this at home if you boil some eggs and some not. Try this, look. A boiled egg, let's see, if I just get, I'm going to do one at a time. In this plate, I'm going to spin the egg. I don't know which. They're both as heavy. I'm going to use this one here. I don't know. Look, if I spin the egg, I'm going to spin the egg. And it goes around and around and around and around. If I suddenly tap the egg, it stops spinning. I'll do that again. Spin, tap the egg, and it stops spinning. Straight away, it stops spinning. Spin, tap, stop spinning. That's because the whole egg, even the inside, stops. So I would say this is actually boiled because it's stopping. If I grab another egg, let's try this egg here, and I spin it, not only it spins a little slower because the inside is runny, it's harder for it to spin, but if I tap it, it doesn't stop spinning either. Magic. So spin the egg, tap, let go, and it still spins. That means this is raw. So this is not a boiled egg. And this experiment is allowing us to know, there we go, that this is raw. So if I want to crack this egg and cook it, it's all right. I don't need to cook this egg because when I spin it and I tap it, it stops from spinning. Is this physics or is this chemistry? See, I'm not mixing chemicals and having them change. So this is physics. Physics is something that you do that involves forces, energy, but not really change in the chemicals you're using. This egg is not changing, it's just moving. So this is physics. Actually, something interesting with eggs is this. I also know that one of these eggs might be off because in this here, I have eggs of many different kinds, and one of them I know is quite old. So I'm going to show you how to find out if an egg has gone off. You just need water. So I'm going to put water here. And eggs are where chickens come from. So right in there, actually, you will never get a chicken unless you have hens at home, and they might be hens that make chickens. Usually these eggs will never have a chicken inside, but they could. And if they were to be made to have chickens, that means that in there is the egg that could turn to a chicken, and it actually breathes a little bit. There's little pores. Anyway, if I put an egg in water, does it sink or does it float? Oh, that egg is floating. I've got to tell you, eggs should not float. See, if I take this egg that I just used before and I leave it there, it sinks. This is the boiled one. Does the boiled one sink or float? It sinks. So eggs actually sink, but that one there is floating. And it's floating because it's made too much gas inside. That means it's actually starting to rot. I would not cook this egg to eat. Because it's floating, I know this egg is off. Even egg floats, it's off. It's starting to make gas. And usually gas can come in and out the egg for the chicken to breathe when it's there. But when they rot, they make a lot of gas. And that means they can't get rid of the gas fast enough and they float. They become like a boat. If an egg floats, don't eat it. This is physics still. So if you're testing your eggs, if you're thinking about physics, let me show you a bit more. And actually, physics, I can write here. So we did the cabbage experiment, and that was chemistry. Now I'm going to do the the egg experiment is physics. Testing eggs. If you fry an egg and then you cook it, that's chemistry. Then the egg changes. But let me show you another chemistry experiment here. Look, in this bowl, I'm going to put a candle. This is something that I thought of showing after the cabbage juice that I showed you before, because this does quite a cool thing in a similar reaction to the one that you saw before. In fact, exactly the same reaction. If you do this at home, ask your parents. You need a bowl and a candle shining in the bowl. So there's the candle. I am going to put in this bowl a little bit of vinegar. So we've got a candle which is being lifted up by another candle below it, and I'm pouring a little bit of vinegar. Try this at home. It's really cool. Just because it's got one of these tea light candles, ask your parents to help with the fire. But I'm going to do the same chemistry experiment that I did before. I'm going to put a little bit of baking soda. That means that the vinegar in here is going to make bubbles. You know, when you mix vinegar and baking soda, a lot of bubbles come out. And you might have wondered, what are those bubbles? The bubbles are actually carbon dioxide. It's what you breathe out. If you all breathe in, you're breathing oxygen. And when you breathe out, you breathe carbon dioxide out. We are going to make carbon dioxide. Carbon dioxide is also what is inside fire extinguishers. So if you ever see a fire and someone uses a fire extinguisher, they're putting carbon dioxide into it. So I'm going to put a little bit of baking soda into what's going on in here. So look, in fact, I'm going to switch the light off so that you only see the candle light there. And I'm going to put the baking soda into the vinegar. We see a lot of bubbles being made. Carbon dioxide is being made. And the candle has gone off. Let me switch that candle on again. Oh, let me switch that candle on again. Oh, let me switch that candle on again. No way! I can't! Why can I not switch, I mean burn the candle on again? I can't. And you might think, maybe it's because I'm using this barbecue lighter. Whenever the barbecue lighter goes into the bowl, it doesn't work. But it's not the barbecue lighter. I could be using matches. Look, here's a match. I'm going to put the match in the bowl again. And I can't. So the bowl is full of the gas that came out of the vinegar and the baking soda. And that is carbon dioxide, which is in fire extinguishers. So this bowl is like a fire extinguisher. We have just made a chemical reaction that allows us to extinguish any fire. There. If I blow, then I'll be able to light the candle up again. There we go. And it's working again. And we could do it again, actually. If I now, once again, put the baking soda into the bowl, we will make more gas. Maybe not as much as before, but I'll try again. Baking soda, vinegar, gas coming out. Actually, it's not making much at all. Ooh. So maybe these reactions really only happen once. Oh, there we go. There we go. The bubbles, carbon dioxide coming out, and the candle going off. And again, the bowl is full of carbon dioxide, so I won't be able to light it up. This is chemistry, once again. Making a baking soda fire extinguisher. That's chemistry. Carbon dioxide, CO2 fire extinguisher, which is actually a really important. And the fire extinguisher here, very similar. We've done one physics experiment. I'm gonna head towards the end of our time, but I've got many things, by the way, in a kitchen. It's like when I was in the garden last week, I could just keep going forever. But since we've done 2 chemistry experiments, let me show you another physics experiment. And now that we are all still in a bubble because of the COVID-19 virus, this is something that I have seen many times, and I really like it to finish the session so that you realize one thing that should happen a lot in your kitchen. I'm putting water in this plate because I'd like you to see something floating on it. Anything that floats in the water will do this. I have some pepper here. I did it with some oregano the other day, and that worked too. See, I'm putting heaps of pepper on the water. Imagine this is a virus in the water. Imagine this is not pepper, but it's a virus. We would want to get rid of it. Something that they are saying a lot that we should do is wash your hands with any kind of soap, because soap is actually good for 2 reasons. One, it actually helps things get off your hand. So if you had a virus in your hand, it would get off. If you're cooking and you've touched chicken and that could have bacteria, wash your hands and the bacteria will just run off your hands. If you have oil with soap, it'll just run off your hands. But for a virus, it's also good for a second reason. The soap will actually break the virus. And once it's broken, not that you can kill it, because viruses are actually not alive, but it just won't be able to get to anyone. So really cool to see how the soap can get rid of things. If you put a little bit of soap in your finger and you touch the water, look what happens. It's like magic. Can you see that? Away from my finger, all the pepper in a circle is heading off. And that is really cool. Any oils, anything, once you break actually the surface tension of the water and the soap can interact with those particles, it goes all around. You can try at home. Put a little bit of soap in your finger and in some floating pepper, see how it moves away from you. This is physics as well. We are not changing the pepper. We are not changing anything. I often say that chemistry is all we do in our kitchen, but I think with this idea of listing the things we do in our kitchen, like washing our hands, washing the dishes, cooking, chemistry, washing, it's more physics really. Your kitchen is a physics and a chemistry lab, and I reckon you do just as much of both those things. Not only chemistry, but also physics. I'm going to put here We did the eggs experiment. Now we've done the pepper experiment with soap. Pepper experiment with soap. That's physics. So we did the cabbage and the fire extinguisher chemistry. We've done the eggs and the pepper. And let's see the time. Actually, it is just about past. So I'm going to leave it in that. There's so many experiments. In fact, you don't have to plan an experiment. Whenever you are in your kitchen, you are doing an experiment. So enjoy it. Enjoy the experiment and think, hey, is this physics? Is this chemistry? What will happen if you burn toast? Actually, that's chemistry. Not good chemistry. You don't want to burn anything in your kitchen. But if you cook it just a little bit, the right time, delicious experiment. So enjoy your kitchen. And if you're at home, I'd like you to, while you're doing lunch soon, maybe, think about that. What kind of science are you doing? Physics or chemistry? Make 2 lists. Maybe with your teachers. Think further about this. What you do at home. Biology, geology in your garden, physics, chemistry in your kitchen, in the bathroom, when you're in the bath. Are you doing physics or chemistry? Same thing. Make a list of as many things as you can think that you do at home and see if they are physics or chemistry. Because science is everywhere. Science is amazing. And it just can help you understand more what's going on. So I hope you enjoyed this. If you have questions, keep putting them there. If you have any questions, get in touch with me through my email. Fun Science YouTube channel will have heaps of videos coming up as well. And go to the museum website. The Otago Museum has heaps of hands-on things that we are putting as well. So it is 11:30 now. That's the end of my half an hour. But do keep enjoying science. And hey, if I'm in Wellington later in the year, I will go visit you. So be ready for my visit later on when we are out of our bubble after the pandemic. See you later and all the best. I'm going to go like this. My phone is hanging right here in my kitchen, which is kind of weird. All right, Tori, Bridget, Jimmy. I don't understand a word of what you're saying, Jimmy. I am not a robot. I can't even read that. But thank you. Thank you, Sophia. And thank you, Karen. Thank you, everyone. See you later.
What time's your next?
Okay. Can we do the swap and then I can use my phone? Thank you. That was perfect. Is it still going?
Yeah.